Good morning and afternoon, everyone. Welcome to today's webinar, Real-Time Fraud Detection for an Improved Customer Experience. My name is Alicia and I'll be your moderator today. Before we begin, there are a few housekeeping items I'd like to review. Today's webinar is being recorded and you are currently in a listen-only mode. You may submit any questions you have throughout the webinar via the Q&A or chat function in the lower right corner of your console. You can also follow us on Twitter at MemSQL or live tweet us during the webinar using hashtag MemSQLwebinar. We will address everyone's questions towards the end of today's presentation. After today's webinar, you will receive a follow-up email with a link to the recording and slides. If you wish to contact us, please send us an email to team@memsql.com. Let's begin today's presentation on real-time fraud detection for an improved customer experience. In this session, we'll explain how leading retail banks and credit card issuers fight fraud for prevention, as well as the reference architecture successful business partners are using to support this key capability. In addition, we will demonstrate how MemSQL gives fraud detection services an edge by delivering a high-performing data platform that enables faster ingest, real-time scoring, and rapid response to a broader set of events. With that said, I'd like to introduce our speaker, Mike Boyarsky. Mike is a Senior Director of Product Marketing at MemSQL. Mike has extensive experience in databases and analytic technologies, having worked at some of the leading database and BI tools in the space. Thank you for joining us today and welcome, Mike. You now have the floor.
Awesome. Thanks, Alicia. Thanks, everyone, for attending today. So we've got a pretty good agenda talking about our experience and sort of the ways that MemSQL can support real-time fraud. So today's agenda, we're going to cover the new data initiatives for banks. We'll then, of course, talk about fraud detection, in particular, some of the challenges and opportunities around that use case. And then we're going to get into more depth around real-time fraud with an actual case study, one of our customers that is currently using MemSQL for this particular application. And then for those that are new to MemSQL, we will spend a few minutes just highlighting our offering and what makes us different and why customers choose us for their database platform. So I'll spend just a few minutes. Sorry about that. I was on pause there for a minute. So we're going to spend a few minutes just talking about the role of digital for banks. There's a lot of transformation occurring. There's a lot of value in moving to a digital experience. Digital transformation, according to this survey in 2019, was the top priority in terms of for banking investment in technology. It is all about creating new sources of revenue through digitizing the experience, digitizing the operations, and delivering new services and products to the market. And these initiatives are, in fact, creating some pressure on data infrastructure. What we're seeing in a lot of our customer interactions is this ongoing effort to eliminate the amount of event to insight latency. We're seeing a lot more continuous data-driven actions and decision-making. So historically, there was a lot of effort put on looking back in time and trying to identify new insights to drive new decision-making or planning on a go-forward basis. In today's market, we're looking at companies that are trying to do continuous analytics on their day-to-day or minute-by-minute part of their business. There's also a need for doing more adaptable insights, and this is really a recognition that as more and more customers interact with banks using different channels, the business needs to respond to the changing conditions of their customers. And so you need a platform and a data infrastructure that can adapt to those changing conditions. And this is really ultimately about enabling your data to perform in real time across the live data that's coming into your operations, as well as matching that with your historical insights. We're also seeing a rise in the requirements for SLA-driven analytics. This is all about delivering the best possible experience for your customers. We have customers that want to deliver real-time dashboards for their customers so that they're getting the same experience that you would want of your internal operations teams. So this is millisecond response times, or just a time frame that's guaranteed in terms of submitting a query and getting a response back. So there's more and more queries that we're seeing that fit into this service level agreement window. So we actually have customers that need all of their queries to run within a 200 millisecond requirement. And that's ultimately to deliver the best experience for their end clients. And to enable that, we're seeing a need to take advantage of more of this tiered storage architecture, so you can blend the use of in-memory and disk-based technologies, even the chipset architectures, to get the best possible performance of your data. So that's ultimately what's driving some of that, those requirements. And then we lastly see customers that want to innovate, but they want to innovate using the existing operations and skills. So this means not throwing out all your technology, but augmenting or supplementing what's already in place, so that you can keep the compatibility with your existing tools, leverage those existing skills, whether they SQL or some standard technology, relational technology, and also provide a path for cloud adoption. So cloud native technologies that work in multi-cloud or hybrid cloud configurations are the technologies that we find banks are investing in. So if we go back to fraud detection, just more broadly as a business imperative, the market for fraud detection is actually significant. It's moving from, in this study, 14 billion in 2018 to 34 billion in 2024. It's just a recognition that fraud is becoming very challenging, and it can be addressed and augmented with technology. And then if you look at some of the data points around just the rise of fraud, 126% rise in events between 2017 and 2018 in stolen personal identity data, so PII data, 58% increase in fraud between 2016 and 2017, just overall by a agency called Ideology. And then this report from RSA, which is very impressive, 600% increase in mobile fraud over the last 3 years. So obviously, as more transactions are occurring on mobile channels, the reality of fraud occurring on that sort of engagement path is going up. And so this is the reason why fraud as a category is very high spend area, and then also an area for continued improvement. And fraud is very broad, so there's lots of ways to apply fraud to your banking business, whether it's for online payments, whether it's for detecting insider trading, building or creating new accounts with the advent of some of the fintech companies and allowing for really easy account creation using a mobile device in a few steps. The ability to detect and identify new accounts, identify whether they're valid or not, and that really blends into the synthetic identity issue, which is fake accounts, using a blend of different information from hacked information. So this creates a very complex, hard problem for banks to mitigate against, but also they want to provide the best possible experience to their customers to compete. So the more gates, the more the steps in the process, sort of reduces that and impacts that experience for customers. So you have to figure out that balance between enabling a frictionless digital experience, but also protecting the assets of your business. Fraud detection, as most should know, is very much powered by analytics. The ability for you to apply data to detection, whether it's through anomaly detection or predictive classification or clustering. There's a number of techniques in the sort of advanced analytics business or market that can help with fraud. And so this is where the game really gets fought, is identifying the appropriate model and analytic functions to identify what may be suspicious or something to block or approve. And having the sort of advanced analytics powered by big data, to find the best fit, to find the most accurate models, that's where a lot of the sort of art and science of fraud detection exists. And so what we're seeing is a sort of next gen for fraud detection is moving to more continuous model refinement. where you're able to optimize your loss prevention and create ultimately the best customer experience, but you're at the same time trying to reduce the cost to your business. And so this is where we think there's a lot of opportunity in the fraud market, is to look at taking what's already in place and then adding to that with a continuous improvement model underway. And so with that, I'm going to spend some time exploring and talking about a real case study of one of our customers that's working on using MemSQL for their fraud detection purpose. And so in this application, it's a credit card solution. And ultimately, they were looking to deliver a high performance yet agile fraud detection platform using standard SQL. And so I'll talk about what that means around agility and some of the sort of performance demands they have. They have a 1 second budget from the time the card is swiped to the approval. So there's a very sort of sophisticated set of queries that need to be run in a very short window of time. So they have about a 50 millisecond budget to work with to run a number of queries. And so in this application, they are looking at about a 70 value feature record. And so we'll spend a little bit of time on how that looks in this sort of walkthrough diagram. So in this application, there's the request. So that request is, of course, some event, a transaction at a terminal or some point of sale system. It hits in that event is collected into their OLTP application. It's a transactional operational database that is collecting that information. And that query is then sent from that OLTP app into a number of disparate queries that hits their various models that they have defined to identify this event and match it against a number of other activities that may have occurred over time. And in this application, again, it's roughly 70 queries that are being run. And so it's running events like trying to identify engagement between this customer and that vendor over the past, month, days, years. So they're trying to identify a trend around that customer and that merchant. They're also looking at other activity like geolocation, event information about prior sort of transactions in the location that event took place in. So there's, without listing every single query, just think of it as there's a distinct number of queries that are being run all in parallel against a reference store, which is on MemSQL. So we are the real-time operational data store. And so this is all about delivering, a check against a fairly sophisticated model to do a score. And so the data is analyzed, and MemSQL will score against these 70 odd queries and provide essentially at the end of the day a yes or no against that most recent transaction. And so that scoring service can occur within the time frame that they required, which is it was around a 50 millisecond window. And what ultimately this particular customer was looking to do was get to more agility so that they can ultimately add more feature extraction queries over time, so that they were looking to essentially optimize their model using continuous insights of their data. So think about this as a continuously moving model that needs to adjust to the insights that they're gaining on the different and new fraud techniques that some of their customers are taking advantage of. And so when you compare and contrast before the previous solution that before they were using MemSQL, they were taking advantage of nightly batch jobs, and they were accumulating these feature records for each customer, doing sort of overnight analysis and trying to identify if the score in fact was correct or not. So in many cases, some fraud events were getting through the system, resulting in lost revenue. And Also, the other challenge that they had was they couldn't change their fraud model. So they're iterating of features and adding new queries was very slow in their sort of update process. So when they could identify a fraudulent profile or fingerprint, it took them in some cases many weeks to make an update to the system in order to identify that fraud on an ongoing basis or go forward basis. So they moved to MemSQL for a couple reasons. One was they wanted to get to a fairly sophisticated number of queries running concurrently, all within this 50 millisecond window. That was something that was a struggle for them with the prior system. It was inconsistent, so they weren't getting the reliable performance. So I talked earlier about SLAs and getting their queries to run in a guaranteed window of time. But ultimately what they got from MemSQL that they were really excited about was the ability to add new features to their model scores using standard SQL and do that on a more iterative basis. So this was giving them the flexibility to do further updates to their platform without having to re-engineer the system or wait for a lengthy sort of change management process that was part of their prior system. And a lot of that had to do with the fact that they were using some technologies that were non-standard, meaning non-SQL or non-relational based. And so ultimately what they are able to model out was that this continuous improvement and this real-time sort of refinement was going to save them literally tens to potentially hundreds of millions of dollars and sort of loss fraud events. So for them, it's all about getting more agile with their fraud detection platform, using standard SQL, getting the great performance so that their customers don't notice any disruption in their experience and service, and then of course saving money and making money from that more advanced service. So I'll then transition a little bit for those that are maybe new to MemSQL, just highlight sort of what makes us tick, what makes us a great solution for something like fraud detection. It starts with our tagline, which is that we call ourselves the No Limits database because of our architecture. So I'll get into some of that in more depth, more technically, but ultimately we are a distributed scale out system. So therefore our ability to support the growing workloads and the growth in data is very easy to do because it's just a node-based scale out system. And then of course we also have innovative lock-free architecture, which allows us to support the continuous ingestion or continuous data movement that's part of many of these more modern applications that we call operational analytic applications. So we do consider ourselves an operational database that can do very fast analytics. So what sort of classic use cases or types of deployments that we support are those that require analytics that require some service level agreement. So that means running your queries in a window of time to power some external service or to power an operational process that's internal that needs to be done continuously. We do see a lot of our customers taking advantage because of ML and AI and the sort of value that that creates to the business. We see a lot of customers taking advantage of real-time ML with MemSQL. We talked about this in a prior webinar, so if you want to take a look at that event and recording, you can go to our website. Just go to memsql.com/resources, and there's a webinar track there, and you can take a look at that that update. We get into some depth about how we support ML. And then ultimately, we see a lot of customers trying to make a transition from their legacy sort of on-premises architecture to the cloud, but doing it in a flexible, adaptable way. So this means not having to necessarily pick and choose which cloud vendor you're going to build your application logic on. You can run MemSQL and deploy that on any cloud and or on your own on-premises infrastructure. So it's all about the flexibility. And as you can see on the right, we're used by a lot of banks. A lot of banks like the performance of MemSQL. They like the familiar relational SQL. and we typically see, us beating out the competition on a price performance basis on a regular basis. Our sort of claim to fame is around delivering speed, scale, and SQL all in one package. So of course, most databases will say they're fast, but I would argue that MemSQL is probably, if not the world's fastest database, because of our ability to really optimize the entire pipeline of data to the platform. So that includes the ingestion. We have a lock-free architecture, so that means we can handle streaming events from Kafka or custom, application logic and or change data capture logic. So just think of our system as being able to efficiently take data into the platform and then run queries on that data as fast as anything, any other data warehouse product in the market. So that includes the great, legacy platforms like Teradata and Vertica and others, and also some of the newer cloud-based data warehouses. We are fast. We are a column store engine. I'll talk a little bit about our sort of underpinnings in our architecture in a moment, but it's all about speed, getting data in, and then the data, once the data is landed, running those queries as quickly as possible. I mentioned earlier about our scale. Our scale is powered by our distributed scaled out architecture. So it's a node-based shared nothing architecture, and so that's what makes us really, really fast. And we believe strongly in relational SQL because we think that's the easiest way to get data out of your system. It works really well with existing tools, but also more importantly, it works with the skill set that is inside most organizations. In terms of our architecture and ecosystem support, as you can see on the left, we can ingest data from a variety of sources: Kafka, HDFS, S3, Spark, or custom file systems. So our ingestion technology is top notch, and that's one of the reasons why a lot of customers, mostly banks, really like our platform. It just works for those types of high ingest environments. And then once data lands into MemSQL, we have two different storage engines. You have a in-memory based row store that's really fast for point lookups, transactions. We are fully ACID compliant. And of course, we also have a column store engine that looks and feels like a traditional data warehouse, so great compression. It can query and do fast aggregate queries. We did a performance test on a 1 trillion row scan in a second. So very, very fast data warehouse as well. And then all the flexible data types that you would expect of a modern database, whether it's JSON, whether it's relational structure, key value, time series, etc. And our deployment flexibility is described mostly based on our Kubernetes and container support. You can run us on anything, whether that's in the cloud or on your own on-premises infrastructure. Of course, if you want to run it on bare metal or some Linux environment, you can do that as well. And just lastly, getting into a little bit more depth on our architecture, we are full ACID compliant. So that means your transactions can be committed, guaranteed, and logged to a disk. So that gives you all the sort of comfort that we treat every event as its own entity. We are fully ANSI SQL, and we have all the flexible data type support that you would expect of a modern database. Our ingestion is again world-class. We can do parallel stream ingest. We can ingest directly to row store or column store or both. It depends on your application needs, and that's ultimately why customers really like the platform, is it gives you this flexibility to determine what's the best outcome, the best process flow to get the SLA result that you need. And we are shared nothing, very massively parallel, high concurrent database. So that means if you've got lots of users accessing your system or lots of data ingestion points coming into the system, concurrency for our platform is really not a challenge. And we were built in the cloud, so we were, came to be about 5-6 years ago. So we took advantage of, distributed processing, all the sort of cloud native functions that you would expect, like Kubernetes and containers, making us a really good choice for those modern cloud-based platforms. So that kind of wraps up the sort of story of MemSQL, how we can be applied to the real-time fraud detection world. Obviously, there's lots of depth that can be gone into around the types of functions and queries that are required of a fraud detection application. And our goal here today was to give you a sort of a starting point to understand how we might fit for a fraud or real-time fraud application. We recommend that if you have questions about today's session, or if you want to go further, you can ask them now and we can do our best to answer those, or set up a call with us and we can get even more depth and provide more sort of personalized demonstrations for your particular application or challenge. You can take a free download of our product. We have a free version available for at the URL there. It's a no time bomb version of our product. You can deploy it to production. Of course, it is limited by its scale and the number of nodes deployed, but we'll argue that you can do a lot with what's available there. And then you can get support from our forums, which is community driven, but also supported by some folks here at MemSQL. So with that, I'm going to now transition it over to some questions. If folks do have questions, by all means, please submit those into the Q&A box, and we'll do our best to get those answered right now.
Thanks, Mike. So as a reminder, you may submit questions to the Q&A function located in the lower right side of your console, or you can tweet us using hashtag #MemSQLwebinar. So we'll start with this one question. How does MemSQL compare to Cassandra?
Yeah, Cassandra's used pretty heavily in the fraud detection market, and it's largely because of the ingest. The couple things. One is the ability to ingest data into Cassandra is very, very solid. It doesn't go down, so it's always available. Challenge with Cassandra, though, is if you want to do any sort of advanced additional query logic, we have found that customers really have a hard time getting the insights out of Cassandra. So it's okay for running a well-defined analytic function, but if you want to change that analytic function or iterate it quickly, that's where the limitations come into play. So Cassandra is obviously, it's a NoSQL system. That means the data, their join support and their sort of ad hoc query support and their ability to run, additional sort of query functions and analytic functions, it's not standard, right? So they have their own query language. So first of all, you're going to have to learn that. In terms of the ingest performance, we have a benchmark on our blog post. If you want to search for Cassandra on MemSQL's website, you can see how we perform against Cassandra from a query ingest perspective, as well as a data ingest perspective, and as well as a query response perspective. And so we are on par, if not better, with the ingest requirement. And then what's the best about MemSQL is you're getting a relational SQL environment, whereas Cassandra, you're getting their own custom implementation of SQL, which means you have to learn their language, and then you have to suffer with the lack of join support and some of the other data structure models that they have to require. So you're getting a little bit more complexity around doing more continuous improvement of the analytics. So that's sort of the takeaway is get the same, ingest performance of Cassandra, but then get the power of SQL using the MemSQL platform.
Can you explain how MemSQL Pipelines works with Kafka?
Yeah, so in terms of ingest, MemSQL does have support for a number of sort of ingest techniques, whether it's file systems, whether it's S3. With relation to Kafka has a built-in connector with MemSQL. So what that means is you can, in a very simple way, using one command line or one function called start pipeline, it essentially automatically configures and identifies the connection point between your Kafka topic into MemSQL. What that means is it's very easy to set up. There's not a lot of sort of hand-wringing and custom coding required to connect a Kafka environment to MemSQL. And then out of the box, you get exactly one semantics, you get extremely high throughput, and then you can do really sort of fun things like put stored procedure logic onto the Kafka stream process. so that you can do potentially scoring on the stream if you'd like. You can, also do pretty advanced things around doing sort of logic on the data movement of Kafka into MemSQL to sort of identify where to land the data, in particular on a node basis or particular type of table. So there's a lot of power that you can get with Kafka MemSQL. It's probably the reason why I think it's probably the #1 ingest technology that's used in conjunction with MemSQL. So it's a top-notch feature, and it's really well regarded within our community.
Thanks, Mike. Can MemSQL be used with Hadoop, and how do customers typically deploy in that kind of environment?
Sure. Yeah. So Hadoop, we see more and more being used as a archive storage layer. So we can do a couple things with Hadoop. One is you can stream data into both MemSQL and Hadoop concurrently. It's kind of your sort of classic Lambda style architecture. And so that means you can use MemSQL to do your analytics on the most current active data. And then your Hadoop cluster can be used for other types of analytics, more data science oriented or just archival style analytics. We do see some customers also landing data first into Hadoop, and then they use the HDFS connector to pull data from HDFS into MemSQL. And you can do that in a continuous fashion. So there's an ability to sort of trickle in or stream data in from Hadoop directly into MemSQL, and that allows for sort of land once and then pull into MemSQL for spot queries or sort of maybe a segment of queries or a segment of data. And then when that period of time ends or that query sort of project goes away, you can flush the system of MemSQL and keep all your data in HDFS. So there's a lot of different ways that people use MemSQL with Hadoop, and it has a lot to do with the application and sort of the query requirements that you have. But I guess the net of it all is our HDFS pipeline is super robust and very commonly used to accelerate query performance of Hadoop. You get that nice relational SQL structure, all that interactive query response that you want, and then when that sort of window of time goes away, you can just always flush the MemSQL system and keep all of your data in Hadoop for other purposes, like data science and other sort of more predictive model development.
Awesome, thank you. Thanks everyone for all of the questions. For those of you with questions we did not get a chance to address, we will follow up with you directly. I want to thank Mike and each of you for attending today. Just a reminder, we'll be sending you a follow-up email with a link to today's recording and slides. If you have any questions in the future, you can send an email to team@memsql.com. We invite you to learn more about MemSQL at memsql.com or give us a try for free at memsql.com/download. Again, thank you for participating and have a great remainder of the day.